All right, I'm going to be talking about reactivity today. Now, reactivity is pretty simple. It's mainly just there's a list of rules that you learn, and then you can compare the reactivity of different elements. The reactivity rules are on the last page of the notes. They are the second to last section. Lewis structures is the last section, so this is right before Lewis structures. Okay, and they mainly deal with 4 families. Well, 5 families. They mainly deal with 5 families. Okay. So first off, let's just go down the rules, and I'll point out where we're talking about on the periodic table. So first one is that the most reactive metal is francium. Second is that the most reactive nonmetal is fluorine. Okay, so as you move away from these, reactivity tends to decrease. But I'll point out more of that later. Okay, the noble gases are inert. Now, inert means that they do not react at all. Okay, noble gases don't react at all with anything. Okay, now, supposedly, if you put them in very specific circumstances, you can get one of them to react, but for our class, they're inert. It's the easier way to do it. They're inert. Okay, the alkali metals, which is the family that francium is in, all those 6 elements are the most reactive metals on the periodic table. None of them are quite as reactive as francium at the bottom, but in general, they're more reactive than anything else. Okay, and right next to them, the alkaline earth metals are only slightly less reactive. Meanwhile, on the other side of the periodic table, the halogens are the most reactive non-metals. Now, these families are the most reactive for the same reasons. It's because they only need to move 1 electron in order to fulfill their outer shell requirement, in order to meet that octet rule. Halogens will do absolutely anything to get 1 more electron. Meanwhile, the alkali metals will do anything to get rid of the 1 electron that they have in their outer shell. Alkaline earth metals, same thing, but they have 2 that they want to get rid of. It's very, very common to see compounds made up of these and these. Most of the compounds that you're probably going to be working with for a little while are going to be alkali metals and halogens or alkaline earth metals and halogens. And that's why they're both so reactive. They tend to react with each other and they form very stable compounds when they react with each other, because this one has the electron that this one needs. I'm pointing in the wrong spot. This one. Next, metalloids are the least reactive elements except for the noble gases. Okay, these don't react at all. These, the noble gases. These, the metalloids, will react, but not very well. They don't react often. It's another case where some of them require very special circumstances. But anytime you get a list of elements, if one of them is this is the least reactive element, unless one of these is also present. Now, reactivity decreases as you approach the metalloids and increases as you approach francium or fluorine. So let's start off with the nonmetals. Okay, now, this excludes the noble gases. Okay, we're ignoring the noble gases for this. So as you move up and over, reactivity increases. So carbon is less reactive than nitrogen. And nitrogen is less reactive than oxygen. Oxygen is also less reactive than sulfur. Okay, so as you move this way, reactivity goes down. That's why, sorry, I misspoke. Reactivity goes up as you move that way. That's why fluorine is the most reactive non-metal, except, well, yeah. Chlorine is slightly less reactive than fluorine. Bromine is slightly less reactive than chlorine. And iodine is the least reactive of the halogens, but it's still not very stable. On the other side are metals. It's the same thing, but upside down. So as you go down and over, reactivity increases here. Whereas going up and over increases it up here. So silver is more reactive than copper, and gold is more reactive than either of them. Now, what about uranium compared with osmium? Since uranium is farther down on the periodic table, it's going to be more reactive. Okay, it's also much closer to francium than osmium is. Okay, and that's because this whole row goes right here. All of these go in this spot here. So this is way farther away from francium than uranium is. Uranium is only 5 boxes away. Osmium is closer to 25 boxes away. So uranium is going to be more reactive. Now, this is a general trend. It doesn't work 100% of the time, but it will work for our class. Now, I'm posting an assignment that's got several lists of elements. So they're in groups of 4. And for each group of 4, I want you to tell me the most reactive element of the list and the least reactive element in the list. Now, if I'm posting this online, it's going to be a picture. So you're going to have to write down your answers on another sheet of paper, take a picture of that, and send it to me. And I can check it and let you know how you did. That's it for reactivity. One day,